Hello, everybody. Greetings, everybody. Welcome back to my Trick Hub. And thank you for tuning in. So, guys, we're preparing for the upcoming trial exam, the upcoming trial exam in September. So, today we're going to do paper 2. We're going to do paper 2, physical sciences. Okay. So, I have this is from the province of Limpopo. Okay. This is from Limpopo province. This is Limpopo province, and we're going to do the second paper, paper 2. So it's 150 marks, and it is 3 hours. Okay, it's 3 hours. So, okay, let's get into it. Let's see. So question 1 is multiple choice questions. Let us begin with question 1. So this is chemistry. It's paper 2. Okay? So they're saying here, 4 options are provided as possible answers to the following questions. Each question has only one correct answer. Choose the correct answer and write only the letter A to D next to the question number 1.1 until 1.10 in the answer book. 1.1, what are they saying? They say, which one of the following compounds is unsaturated? Okay. Unsaturated means it has multiple bonds at some point. Okay. Meaning it has multiple bonds. Okay. It can't be A because A is saturated. A is an alkane, you see. A is an alkane, so A is saturated. B is also an alkane because it has a branch here. So B is also saturated. And then C will have a multiple bond here because there is no CH2 here, okay? So C is the one here that is unsaturated, see? C is the one that has multiple bonds because even D is saturated. So our answer here is C. And then 1.2. 1.2, what are they saying? Which of the following is the functional group of ketones? Okay, ketones, because ketones are like how they have a functional group like this, isn't it? So is it a carbonyl group, carboxyl group, formyl group, and hydroxyl? It has a carbon, so it's a carbonyl group, you see, because the functional group of ketones looks like that. So our answer here is A. Is A, carbonyl group. And then C, they say, which of the following pairs of organic compounds are chain isomers? What are the chain isomers? It means they have the same molecular formula, but they have different structural formula. They have the same molecular formula but different structural formula. So butane and methylbutane, hexane and 2,2-dimethylbutane, 2-methyl, and then pentane. So we know that it cannot be B. B, D, I meant to say D cannot be the answer because it has the same what? It has even different functional groups. Okay. So the same molecular formula, hexane is going to be C6. And then 2,2-dimethyl butane is also going to be C6. Okay. So our answer here is going to be B. Okay. It's going to be B. Because hexane will be C6, H12, H14, I meant to say. Okay. And then this will be the same molecular formula for both hexane and 2,2-dimethylbutane. Okay. And then, okay, let's go to 1.4. Now, 1.4, they say, which one of the following compounds is a product of the cracking of octane? Okay. Cracking is the what? When you break down large compounds. Okay, so octane is going to be what? C8, H what? H18. Right? Octane is gonna be like this. It has 8 carbon atoms. Okay. So when octane is cracked, what happens? Because the correct answer, octane does not have bromine, it doesn't have oxygen, and it doesn't have chlorine. Okay. So the only correct answer here can be A. Because when you do cracking, you don't add any other compound. Okay. So it means that the compounds that come from cracking can only have C and H. And we can see that for A here is the only compound that has C and H. Okay, so A is our answer here. And then we go to 1.5. So 1.5, they say the Boltzmann distribution curve for a certain gas at a constant temperature is shown below. Sure. So they show us the Boltzmann distribution curve. Yeah. So they say at a constant temperature. And then they ask if the temperature of the gas is reduced by 20%, by 20 degrees Celsius, I mean to say, the shape of the graph changes. What happens to the values of N for the kinetic energies, Q, P, and R? Okay. Okay, for Q, P, and R. Okay, so if it reduces, what will happen? It means the curve will be it will shift more to the left because it will have lesser what? Kinetic energy, isn't it? So maybe this will go up, this will go down, and this will go down a bit. Okay. And then so they're asking us if the temperature of the gas is reduced by 20 degrees Celsius, the shape of the graph changes. What happens to the values of N for kinetic energies, Q, P, and R? So here they're saying that Q will be higher. We know that Q, will it be higher? Yes, it will be higher. And then what about P? P will be lower and R will be lower. So our correct answer here would be, because Q will go from here to here. It will go to there, and P will come here, and R will come here. So the correct answer for 1.5 would be B. Okay. B is the one that says B is higher, P is lower, and R is lower. So the correct answer is B. Okay. Then 1.6. 1.6 is on the next page. So 1.6, they say consider the following hypothetical reversible reaction below. M is a gas plus N is a gas. And then it gives us O and P. So O is a gas and P is a liquid. Okay. Two experiments in which the production of O was measured were carried out. The results are shown in the graph below. The same initial amounts of M and N were used. Okay. So what change in the conditions can explain the results shown? Okay. So we can see that in experiment, the experiment 1 has a higher production of O compared to experiment 2. They say the same initial amounts of M and N, the same initial amounts of M and N were used. Okay. So it means that the concentration did not change. And that's what it means. So now what change? What causes? So it means that in experiment 2, the O produced was less. Okay. The O produced was less. So then what does that mean? You can say a lower pressure was used in experiment 2. A catalyst was used. No, it can't be B because a catalyst does not have an impact. A higher temperature, a lower temperature. Okay, they told us nothing about, we don't know the enthalpy change. So we don't know what effect the temperature will have. So what it shows here is that the reverse reaction was favored because the amount of O is less in experiment 2. So the reverse reaction was favored. So the reverse reaction can only be favored if there is a lower pressure. So our answer here should be A, is a lower pressure was used in experiment 2. A lower pressure was used in experiment 2. Which of the following statements is true regarding the equivalence point of a reaction between ethanoic acid and sodium hydroxide? Okay, the equivalence point. It is the point where the acid and the base have reacted so that neither is in excess. It means hydronium equals to hydroxide ion, pH equals to 7. Okay. Okay, so they're saying, is it A? Is it Roman figure 1 only? Is it Roman figure 1 and 2? Is it Roman figure 1, 2, and 3? And then they're saying, is it Roman figure 2 and 3? So which one is it gonna be? It is the point where this is equals to that, pH equals to 7. No, we know that the pH can be greater than 7 or it can be less than 7 at the equivalence point, isn't it? So it doesn't always mean that at the equivalent point the pH is equal to 7. Okay, doesn't mean that. So this means that the concentration here, the H3O at the equivalence point, can also be greater than or it can be less than hydroxide if the pH can be greater than or less than. So it means that the answer here is going to be A. You see, it's going to be A because the pH can be greater than 7 at the equivalence point. It can also be less than 7 at the equivalence point. If it's greater than or less than, it means that the hydroxide or hydronium ions can be out of balance at the equivalence point. It depends on whether you use the strong acid, strong base, weak acid, weak base. So that's what will determine the pH and the concentration of the hydroxide and hydronium ions. Okay. So let's go to 1.8. So now for 1.8, what is required? They are asking, a beaker contains a dilute solution of hydrochloric acid. A second beaker contains a solution of sodium hydroxide. Water is added to each solution. What happens to the pH of each solution? Water is added. So what happens to the pH? Okay. So hydrochloric acid solution. So the pH, okay, because pH will be determined by, because we know that pH is equal to what? Negative log and then H3O. Okay. So we have to look at them. When we add water, what are we doing to the what? To the H3O, the hydronium ions. Okay. Let me see. So now what will happen here? When we add water, inside the hydrochloric acid, okay, if we add water, the pH will increase, isn't it? Yes, the pH will increase here. And then here, the pH will decrease because Here it will be H3O, which is added, and here it will be OH, which will decrease the pH. You see? So the correct answer here is going to be B. You see? Because remember, guys, water is an ampholyte. If it's an ampholyte, what does that mean? It means that it can be an acid or it can be a base. Okay, so it will depend on the solution. So it will increase the pH in hydrochloric acid and it will decrease the pH in the sodium hydroxide solution. Okay, so that's what will happen here. And then we go to 1.9. Consider the galvanic cell represented by the cell notation below. So I say consider the galvanic cell represented by the cell notation below. And then silver nitrate and silver. Which one of the following describes the movement of ions between the two half cells? Okay. So positive ions move from, is it nickel to silver? And then negative ions from nickel to silver. Nickel to silver, silver to nickel. Okay. So we know that A cannot be correct because the direction cannot be the same. It can't be nickel to silver and then nickel to silver again. Okay. The direction cannot be the same. Again, also here, it can't be silver to nickel and then silver to nickel. Okay. Because the direction should be what? The opposite. So we know that A and C are not true. Okay. Now, the positive ions, okay? The positive ions, nickel is what? Isn't it, if the cell notation is like this, okay? This is the anode, this side. So there will be oxidation. This is the cathode, this side. So there will be reduction. So now, what will happen? This means that the positive ions will move from nickel to silver. Yes, because they will be from this side. Okay, they will move from nickel to silver, from the anode to the cathode. So our answer here will be B. See? Then this is how the cell notation comes. So the oxidation comes from the left here. So there will be oxidation here. Then here there will be reduction. Okay. And separated by the salt bridge here. That's what will happen. Which one of the half reactions below will occur at the positive electrode during the electrolysis of copper chloride? So at the positive electrode, guys, what will happen there? This is where, that's where the negative ions will be attracted to. Right? So when this will be broken down into copper 2 plus and then plus 2Cl, the ion. So at the positive electrons, the positive electrode, right, there will be two electrodes, the negative electrode and the positive electrode. So the chlorine ions, because they are negative, they will be attracted to the positive electrode. And the copper will go to the negative electrode. So they say, which one of the half reactions below will occur at the positive electrode? Okay. During the electrolysis. It can't be this. Okay. It can't be this, it can't be that. So it's the chlorine which is negative. So the correct answer here will be D, because the chlorine is the one that will be attracted to the positive electrode. Okay. So our answer here is D. Okay. So this was 20 marks. It was 20 marks. It was a multiple choice question. Let us move on to question 2. Question 2, they say what? The table below represents organic compounds. Study the table and answer the questions that follow. Okay. So they show you organic compounds here from A to F, A, B, C, D, E, F. Okay. There is IUPAC names, and then there is condensed structural formula. There is so they didn't give us, there is no structural formula in this. So in this table, 2.1, they say define the term chain isomer. So 2.1, they want the definition. Okay. What is a chain isomer? 2.1, they're asking you, what is a chain isomer? So, what's the definition of it? These are what? Chain isomers. Chain isomers are compounds with the same molecular formula. They have the same molecular formula, but different types of chains. This is the definition of what? Chain isomers. And then 2.2, what are they asking for? They say, write down the letter that represents a chain isomer of pentane. Okay. Pent means 5, isn't it? Pent means 5. It means there should be 5 carbon atoms there. Okay. So 1, 2, 3, 4. So the one that has 5 carbon is C here. Okay. So C has 5 carbon, is 1 carbon, and then there's the other 4. So the correct answer here is C. And then we go to 2.2. 2.2.2, they want the what? The IUPAC name of compound B. IUPAC name of compound B. Here we have compound B here. So bromo, that is bromine on position number 2. Well, or is it position number 4? Because it's 1, 2, 3, 4. Okay, so it could be, because the structural formula for B is going to be how? 1, 2, 3. And then 4, 5. So there's going to be other carbon atoms here. So now, how are we going to name this? Okay, the bromine is on position number 4. Okay, here, because we have to start from is 1, 2, 3, 4, 5 carbon atoms. Okay, so there are 5 carbon atoms, and bromine is on position number 4 if we come from the left, because that's where the branches are. Okay, so we're gonna come from the right, I mean to say going that way when we name. So our name here is gonna be 4 bromo 4 bromo, and then 2.2 dimethyl. Okay, let me do it. I don't think the name will fit here. Let me just do it the other side. So it's gonna be 4 bromo 2.2.2. It's gonna be 4 bromo 2.2 dimethyl. We have 4 bromo 2.2 dimethyl pentane. Yeah, it's gonna be like this: 2.2 dimethyl pentane. It's 2.2.2. And then 2.2. IUPAC name of compound D. What is compound D is here? It's CH3, and then CH2, and then CH, and then CH. So how many carbon atoms? 1, 2, 3, 4, 5. Okay. So it has a multiple bond here. So it's gonna have a double bond. So if there are 5, it's gonna be pent. Okay. It's gonna be pent. So then here we're going to say pent 1 in. Okay. Or you can say 1 pentene. 1 pentene, like this. Okay. Can be pent 1 in or 1 pentene. General formula of the homologous series to which compound D. Compound D is the one pent 1 in. So it means that the general formula for alkenes. What is the general formula for alkenes? Is what? It is CnH2n. CnH2n. Okay, and then 2.3. 2.3, we're asked to draw the structural formula of compound F. Okay, so 2.3, I'm going to do it this side. Compound F is what? Methyl propanoate. Okay, so it's an ester. Okay, methyl propanoate. So if it's methyl and then propanoate, methyl means one carbon atom. Okay, methyl propanoate. Okay, methyl propanoate. So it's going to be, if it's an ester, it's going to be C, and then it's going to be separated by an O. So if it's propanoate, it means that the other side we must have 3 carbon atoms in it. And the other side, there is 1 carbon atoms. The other side we have 3. So it's going to be methyl. And then propanoate. Propanoate means there's going to be a double bond here. And then it's going to be like this. Prop means 3, meth means 1. So it's methyl, 1 carbon. Propanoate means 3 carbon atoms, like this. And this is the functional group for what? For esters here, the one that has a double bond. See? So the compound is like that. And then 2.4, what are we required to do? Write down a balanced equation using molecular formulae for the complete combustion of compound C. Okay. Compound C is going to be C5H12. Okay. So there are 12 hydrogen atoms, and there are 5 carbon atoms we can see here. Okay. So 2.4, they want a complete combustion. Okay. Okay. So it's going to be 5 and 12. C5, H12. H is going to be 12. C is going to be 5. Okay. So if it's combustion, it means we must add oxygen. Okay. It's going to be C5, H12 plus so we have C5, H12 plus oxygen, which is going to be O2 and then if it's combustion, it means it's going to be CO2 plus H2O. And then we must try to what? To balance the equation. So if we balance the equation here, we're going to have what? The carbon should be 5. So if we want to have another 5 carbon atoms, we must use a 5 here. And then the hydrogen atoms are 12. So if we want to have 12, the other side, we must use a 6. It's going to be 6 multiplied by 2 is 12. And the oxygen atoms, they are 10 over here. And then there are 6 over here. So 10 plus 6 is 16. So it means that we want to have 16 atoms the other side. So if we want to have 16 atoms, we must use 8. And the equation becomes balanced. And then 2.5, what are we asked to do here? To which homologous series does A belong? A. Okay, A here is a formyl group. So these are aldehydes, isn't it? A is an what? It's an aldehyde. So the answer here is aldehydes. Aldehydes. And then 2.6, they say compound E is an alkene. It's an alkane, sorry, with an extra 20% of carbon atoms than compound C. Okay, so determine the values of X and Y. So they say it has an extra 20%. It has an extra 20% of carbon atoms. So what does that mean? So we have to compare it to compound C. So E is bigger. Okay. So if it has 20% more, what does that mean? It means that it has 6 carbon atoms. Okay. It's gonna be C6 because 20% more than this will be 6 carbons. So if it's an alkane, these 6 will have to be H14. We use the what? The general formula. Okay. It will be C6H14 because they told us it is an alkane. You see? So this means that what? So this means that therefore E is C6H what? H14. Okay. Because we use the what? The general formula. Cn 2n plus 2. 2n plus 2. This is the general formula of what? Alkanes. So it means therefore X equals to 6 and Y equals to 14. That's what we use here. See? It's like that. So now let's go to, so that was the end of question 2. Question 2 was 19 marks. See? Let's move on to question 3. Steel organic compounds. The melting and boiling points of the first 4 straight chain alkanes are compared under the same conditions. Define the term melting point. So they want the definition for what? Melting point. That's the first thing we're asked here. What is the melting point? 3.1. So the definition here, what? Melting point is the temperature at which the solid and the liquid. So the solid and the liquid faces of a substance are at equilibrium. Yes, so this is the definition. Okay. So, and then 3.2, what do they want? They're asking what conclusion can be drawn from data in the table. So the number of carbon atoms are increasing when we go down the table. Okay, and then we can see that the melting point is what? So the boiling point is increasing. Okay, the boiling point is increasing. The melting point is also increasing. I think this is a mistake. Okay. That should be a negative here. Yes, there should be a negative. There should be a negative. I think this was a mistake. So they say what conclusion can be drawn from the data in the table. So we can see that as the number of carbon increase, the melting point or the boiling point. So let's use the boiling point. Okay. Let's use the boiling point as the number of carbon atoms as the number of carbon atoms increases, the boiling point increases. The boiling point increases. So that is the conclusion. Or you can also use the melting point. You can also say the melting point increases, but it's okay. We can use the boiling point. You can also use the melting point. It's not a problem. Okay. So let's go to 3.3. What do they want here? They say, how will the strength of intermolecular forces butane, how will the strength of intermolecular forces butane compare to its isomer? Right, only stronger than, weaker than, or equal to. So butane will be a straight chain. So the isomers will become branched. Okay, so the butane will have, so it will be stronger than, the molecular forces here will be stronger than, its isomers. It will have a stronger intermolecular force, okay, which are the London forces in this case. So 3.4, is this comparison fair or unfair? Give a reason for your answer. Okay, give a reason to your answer. So is this fair or unfair? So for 3.4, this is a fair. Why are we saying it's fair? It's gonna be fair. Okay. Why are we saying that? Because compounds used, okay, compounds compared, or you can compounds compared are from the same uh, homologous series, from the same homologous series. Okay, they come from the same homologous series, which is what is the alkanes. So it is a fair comparison. So that's why we say this thing is a fair comparison. And then 3.5, or they say, in which phase will propane be at room temperature? Write only gas, liquid, or solid. Propane, the melting point is the melting point is this, and the boiling point is negative 42 degrees Celsius, okay? So it's negative 42. So it means that at it will boil at negative 42. It means that it will go from liquid to gas. So at room temperature, it will be a gas, okay? Our answer here is going to be gas. It's going to be a gas because at that point, at room temperature, it's already past its what? It's already past its boiling point. So it means it's a gas. It is a gas at that point, okay? And then they say, explain the difference in boiling point between ethane and propane. Ethane and the difference in boiling point. Ethane and propane, okay? So ethane has negative 89, propane has negative 42. So propane has a higher boiling point than ethane. Okay, so this difference, how do we so how do we explain that? It's gonna be, so for 3.6, we're going to say ethane has less carbon atoms, has less carbon atoms than propane. So what does that mean? So we know that both have London forces. Both have London forces. So which are weaker between ethane molecules than propane molecules. So it will be weaker for ethane than, so those London forces will be weaker in ethane than they would be in propane molecules. Okay, so what does that mean? It means that less energy so it means less energy is needed to overcome intermolecular forces, intermolecular forces in ethane than in propane. Huh? So this is the explanation here. Say what? Ethane has less carbon atoms than propane. Okay, ethane has less carbon atoms. Both have London forces, which are weaker in ethane than propane. Okay, because it has less carbon atoms. Then so it means that less energy is needed to overcome intermolecular forces in ethane than in propane. Okay, so that is the explanation here. Okay. So yes, that is the end of question 3. That is the end of question 3. So it's another question on so this is physical properties of what? Of organic compounds. Let's move on to question 4. So question 4, you can see is already on organic reactions. Okay. So question 4 is organic reactions. Okay. So they say the flow diagram below shows different organic reactions. Compounds P, Q, R, and S are organic compounds. Okay, so they show us the flow chart here. So we should analyze the flow chart here. So then what's gonna happen? So we see P, we have, so these organic compounds, all they come from 2-chlorobutane. There is reaction 1 and reaction 3. So from 2-chlorobutane, it goes to compound P. And then after that, it goes to compound R here. And then after this, so this, we have compound Q, and then we have reaction 4. The reaction 4 gives us compound S, okay? Now, for reaction 1, write down the type of reaction. So reaction 1 is here, okay? So dilute, there is a dilute strong base, you see? There is a dilute strong base here that was used in reaction 1, dilute potassium hydroxide. What is the difference, guys? If you have a dilute base and if you have a concentrated base, what difference does that make? Dilute base leads to substitution. A concentrated base leads to elimination. You see? So if it's concentrated, it leads to elimination. Then if it's dilute, it leads to, if they say it's dilute, then it leads to substitution. You see, that is the different that you should know. Okay. So now they say for reaction one, write down the type of reaction. The type of reaction here is going to be substitution because we have a dilute. We have dilute. So you can say substitution, substitution, or you can say what? Hydrolysis. Hydrolysis, because this is a type of substitution that we have. So it can be one of the two. It can be, you can say substitution or you can just say hydrolysis. It's a specific type of substitution that we have here. Mhm. And then the IUPAC name of compound P. Okay, if substitution happens, so 2-chlorobutane. Okay, so it means that the chlorine is on position number 2. Okay, so what will be substituted here is the what? Is the hydroxide, isn't it? So then you will have an alcohol because the chloro will be replaced with a what? With a hydroxide uh, ion here. Okay, so it will be, if it's butane, it means it will be butanol. Okay, so then the IUPAC name here is going to be 2-butanol, isn't it? 2-butanol, or so it's going to be 2-butanol. Butan 2-ol. 2-ol. 2-butanol or butane 2-ol. Butane 2-ol. So consider reaction 2. So we're going to look at reaction 2 now, meaning we're going from compound P, which is 2-butanol, okay? And then there is concentrated sulfuric acid. So for reaction 2, if there is concentrated sulfuric acid, what does that mean? It means there is going to be elimination, you see? So this is how you know. So there's going to be elimination. So the things that they use is what tells you whether there is going to be elimination or substitution or whatever. Okay. Okay. Or depends on what they tell us about compound R. There is, okay. Okay, let me not rush to conclusion because it could also be esterification, isn't it? It could also be esterification. So now they say reaction 2, write down the structural formula of compound R. Okay, so the structural formula of compound R, again, okay, it means that there's going to be elimination here. Okay, because they never told us anything about compound R. So for 4.2.1, we go to 2-butanol and we must eliminate. Okay, so 4.2.1, there's going to be elimination. It's going to be 1, 2, 3. So if it's gonna be like that, is the elimination is gonna be over here, because if there was two butanol, it was here. The butanol was here, isn't it? If it's eliminated, it will be this carbon, and it will also be this carbon, because elimination goes to a carbon with a fewer hydrogen atoms. Okay, so the structural formula will be like this. It will be like H H H. And then now we go to 4.2.2. They say, apart from concentrated sulfuric acid, what is the other condition for this reaction to take place? The other condition, isn't it, for this type of elimination, okay? This type of dehydration. Again, guys, you can see that you should know the reaction conditions. So the other condition for dehydration is what? Is strong heat, isn't it? Strong heat is another reaction condition that you need for this type of elimination, which is dehydration. Okay. And then for reaction 3, write down the a balanced equation using structural formula. Okay. So you must use structural formula for this reaction, which is reaction 3. Again, like I told you, you can see that it's concentrated base. Okay. So there is going to be elimination that happens. Okay. So for 4.3.1, we start with 2-chlorobutane. Okay. 2-chlorobutane, 4.3.1. Two chlorobutane. 2-chlorobutane. So 2-chlorobutane. Now, when there is elimination and then you add a strong base, so then again, this part here will become what? Eliminated. See? So then on the other side, you still have 4 carbon atoms. See? You still have 4 carbon atoms. So it's going to be C, 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 and then H. And these two will become eliminated. They will be eliminated. So then you'll have a double bond here. H, H, H. Okay. And then the other products that will happen, because now here you will have a concentrated what? Concentrated potassium hydroxide. So what will happen is the stuff that was eliminated here will form H2O, which is going to be plus H, and then there's going to be potassium chloride, K, and then Cl, like that. So now, this is the reaction. So how many marks is that? Is 5 marks. Okay, you can see that then they want the IUPAC name of compound Q. So compound Q happens here. It happens after the what? After the elimination. So it is here, compound Q. Okay, the major product. It will be 2-butene. You see, it will be 2-butene. So it will be 2-butene, or you can say but2-ene. But2-ene. Two-butene or but2-ene. And then reaction 4. The reaction 4, they say compound S is an alkene. Write down the type of reaction. Okay. Reaction 4. Let's look at reaction 4. Reaction 4 comes here. Compound S is an alkene. Okay. So they tell us that compound S is an alkene. So meaning there was an addition, isn't it? There was an addition reaction. So for reaction 4 here, there was addition. If they say compound X is an alkane, it means there was an addition. The type of reaction, okay? Addition, okay, addition, reaction. So this is hydrogenation, okay? Name or formula of a catalyst needed for this reaction. We can use platinum here. We can use platinum or nickel or palladium if we were to do hydrogenation, okay? Now, compound S can undergo cracking under certain conditions. Define the term cracking. Oh, so they want the definition for what? For cracking. What is cracking? Okay, 4.5.1. So what is cracking? Cracking is the chemical process in which longer chain hydrocarbon hydrocarbon molecules are broken down to shorter more useful molecules. So this is the definition. Cracking is the chemical process which longer chain hydrocarbon molecules are broken down. Okay. Broken down to shorter, more useful molecules. 4.5.2. Except for high temperature and high pressure, what is the other condition required for compound S to undergo breaking? So, except for high temperature and high pressure. So, catalyst, okay. So, catalyst is also another requirement. So, we could use nickel or palladium or nickel or platinum. One of the three is the other condition that is you would require here. See? So that is the other condition that we would need here. Okay. Okay, so that is the end of question 4. That is the end of question 4. It was 18 marks. Okay. It was another question on organic molecules, and it was organic reactions specifically for question 4. Okay. Let's move on to question 5. Okay, so we have 5.1, they say define the term rate of reaction. So define the term rate of reaction. So let's just do 5.1 before we read paragraph. Before we read the paragraph, let's do the definition. Rate of reaction, what? Rate of reaction is the change in concentration of reactants or products per unit time. Per unit time. So that's the definition for the rate of reaction. And then let us look at the paragraph, the opening paragraph here. What does it say? Okay. Rolate is a tablet which contains calcium carbonate as one of the active ingredients. A pharmacist wants to determine the rate of reaction between stomach acid and rolate. He performs an experiment using calcium carbonate powder and concentrated hydrochloric acid of concentration 0.1 mole per cubic decimeter. He then performs the same experiment using a lump of calcium carbonate of the same mass as the powder. The reaction takes place according to the following chemical equation. Okay, so they gave us a balanced equation here. They gave us a balanced equation, and then 5.2 says what? What type of reaction takes place between Rolade's tablet and hydrochloric acid? What type of reaction here? This is an acid-base reaction, isn't it? This is a base, this is an acid. Okay. This is an acid-base reaction. Acid-base reaction. This is an acid-base reaction. Or you could also say a neutralization reaction. Then 5.3, they say, what is the dependent variable for the investigation? So, what is the dependent variable for the investigation? Lump of okay, so they say lump of calcium carbonate in the same mass of the powder. So the difference here is that we use the lump, and then at some point we use the what? The powder. Okay, so the independent what is the surface area. That's the difference that it makes it. When you use powder and when you use the lump, you change the what? The surface area of the, so uh, so they say the pharmacist repeated the same experiment using the same mass of calcium carbonate lumps. Which factor affecting the rate of reaction is the pharmacist investigating? Okay, so that's 5.3. So now he used the lumps first, and then after that he used the powder. So the factor that he is the surface area, isn't it? The surface area, because the powder will cover a larger surface area than the lump. So when you change from the lump to the powder, it means that you are investigating the surface area. Okay. What is the dependent variable for the investigation? The dependent variable here is going to be reaction rate. Okay, because the reaction rate here, the rate of reaction or reaction rate, will depend on whether you use the lumps or you use the powder. So the reaction rate depends on the surface area in each case. See. Then 5.5, they say what? In the second experiment, 53 cubic centimeters of carbon dioxide was produced in 1 minute. Calculate the average rate of reaction in moles per second. So, okay. So they want it in moles per second. So it means that we must change the minute into seconds, and the volume also must be in, we must use the volume here to calculate the number of moles. So then we must find the number of moles, and then we must also change the time into minutes. Okay. So they say in the second experiment, 53 cubic centimeters of carbon dioxide. So we can find the number of moles for carbon dioxide there, isn't it? So this is 5.5. Okay. So then we can say number of moles equals to V divided by Vm. So our V here is going to be 53. So this is for carbon dioxide. And then this is for CO2. The volume here, we use a constant. And so it's going to be, if we have centimeters here, then it's going to be 22.4 and then multiplied by 10 to the power 3. Okay? Because we're using centimeters here, not decimeters. So then you use a calculator here, it gives me 2.366 multiplied by 10 negative 3 mole power. Yes, so then if we have CO2, then these are the number of moles of what? Of CO2. So then if we have CO2, we know that we can have what? Or acid of concentration 0.1. So in order to get the number of moles of what? Hydrochloric acid, then we can use the ratio. Right? Can use the ratio here. Then it means therefore NHCl is going to be 2 times. We're just going to take 2 times the what? The CO2. So we take whatever we have here and then we multiply by 2. So it's going to be 4.732. It gives me 4.732 multiplied by 10 negative 3 moles. So if we were looking for the rate of reaction, calculate the average rate of reaction in moles per second. So then the rate of reaction here, reaction rate equals to, will be equal to the change in what? In the number of moles divided by the change in time. So if they say in 1 minute, we are going to say 4.732 10 negative 3. And then in 1 minute, it's going to be 60 seconds. Because they say they want this thing in moles per second. So then you use a calculator here. When we use a calculator here, it gives me 7.89 multiplied by 10 negative 5 moles per second. That is the reaction rate that we have here. Okay. So 5.5 was the last. So we move on. So guys, you leave your questions in the comment section. If there's something you don't understand, okay, you leave your questions in the comment section and I will attend to your questions, okay? So let's move on to question 6 here. Question 6, they say, the following reaction is one of the, the following reaction is one of the steps in the production of sulfuric acid. So they give us a balanced equation here. Sulfur dioxide, sulfur trioxide, oxygen. Okay. And they also gave us the enthalpy of reaction, which is negative 196 kilojoules per mole. They want the definition, 6.1.1. Define the term chemical equilibrium. Okay. Chemical equilibrium. So let us write down the definition. Define the term chemical equilibrium. 6.1.1. The definition, they want the definition. So chemical equilibrium. Chemical equilibrium is a dynamic equilibrium when the rate of the forward reaction equals the rate of the reverse reaction. So that is the definition. Okay. 6.1.2, they say, in an industry, they mix a certain moles X of sulfur dioxide with 0.5 moles of oxygen gas. The reaction proceeds until equilibrium is reached in a 2 decimeter container. Upon analysis of the equilibrium mixture, it was discovered that a quarter of the initial number of moles of oxygen remains. Okay. The Kc value for this reaction is 10. Calculate the initial number of moles of sulfur dioxide. So they gave us the Kc. They say the Kc is 10. And then they also gave us the volume here. The volume is there. They also gave us Ni. And initially, okay, sulfur dioxide with 0 oxygen gas, okay. Okay, so we have to do the table, isn't it? Using the what? Using the balance equation here. So it's gonna be 3 columns. Okay. So this is 6.1.2. So for 6.1.2, there's gonna be this, okay. So now it's gonna be, you should know how to draw the table. The table is not given in the formula sheet, isn't it? So, isn't it there is n initially, and then there is, again, it's measured in moles, okay? And then there is change and change. Again, the change is determined using the mole ratio. N change, and then there is N at equilibrium, okay? N at equilibrium. Again, it's measured in moles. So these are the rows of the table. Again, you should know them. And then the last is the what? Is the concentration, isn't it? The concentration, we get it from the previous row. So C equals to N over V, and then it's measured in moles per what? Per cubic decimeter. So now we're going to divide by the volume on the last row. Okay, so now this is what we're going to do here. The number of columns will be determined by the balanced equation, by how many molecules you have in the balanced equation. So this is it, like it's going to be like this. We're going to have 3 columns in this case because we have 3 compounds. So we look at the balanced equation. Then SO2, SO3, SO2, and then O2, and then SO3. And then so we start with the information that we have. So initially there are no products. So initially here we have 0 for the product. And then they gave us N initially for what? For oxygen. The number of moles of oxygen initially was 0.5. So we have 0.5 here. And then I think they said X for sulfur dioxide. They said what? In an industry, they mix a certain moles X of sulfur dioxide, yes. So for sulfur dioxide, we have X here. And then they said the reaction proceeds until equilibrium in a reaction reached in a 2 decimeter container. Upon analysis of the equilibrium mixture, it was discovered that a quarter, 1/4, of the initial number of moles of oxygen remains. Okay, so 1/4 of oxygen. So it means that we have to say 1/4 multiplied by 0.5, which is equal to 0.125. So then we can use that here. Then we know that the reactants are supposed to be negative and the products are supposed to be positive. We add the products and we subtract the reactants. So we then have to get the number here for the oxygen, isn't it? We have to get the number for the oxygen here, which is, how are we going to get it? We're going to say 0.5 here, and then we minus 0.125, 0.5, we minus 0.125. You use a calculator here. So you minus 0.125. So we're going to get 0. So now in order to get the so to get the rest of the amounts here and here, we're going to use the ratio. We're going to use the ratio. So for this and that, we have a 1 and a 2. So we must multiply this number by what? By 2. And we take this number here, we multiply it by 2. Because the ratio is 2 here. So we take it, we multiply by 2. You use a calculator here. Multiply by 2, it gives us 0.75. And then from there, how do we get the number here? It's because the 2, you have a 2 here, and you also have a 2 here. So they have the same ratio, the sulfur dioxide and sulfur trioxide. Okay. So what it means is that the number that you have here for the change will be the same number that you have here because the ratio is the same. So if you have 0.75 here, then you're going to have 0.75 the other side. It's because the ratio is the same. And then after that, what do? We add, we say 0 plus 0.75. Okay, and then here we can have x minus 0.75. And then for the last row, for the concentration, we're going to use the volume. So we take the number of moles that we have from equilibrium, and then we divide them by 2. So we take all the numbers here, we divide them by 2. So here is going to be x minus 0.75. And then you divide by 2. And then you say 0.25. And then you also divide it by 2. Divide by 2, it gives me 0.0625. Okay. And then we say 0.75 divided by 2. It gives me 0.375. Okay. And then from there, we can go to the what? To the Kc expression. So the Kc expression is going to be the product. We're going to say the product. There's only one product here, okay? And then the others, they are reactants. So there's only one product, which is sulfur trioxide. So for the Kc expression, we're going to say Kc, this is what it should be. Kc is going to be product SO3, and then the coefficients go to the top, and then there is going to be sulfur dioxide, SO2, and then I think oxygen also. So the coefficients come here, and these are the coefficients. The coefficients becomes the exponent. So the coefficients, these are the balancing numbers. In front, there is a 2 here, sulfur dioxide, and there's also a 2 here for sulfur trioxide. So then we can substitute. So we're going to substitute the numbers that we have here. So this is going to be equal to sulfur trioxide is here, oxygen is here. So sulfur dioxide is going to be x minus 0.75 and then over 2 and then to the power of what? Of 2 multiplied by the oxygen, which is 0.0625. And then sulfur trioxide, which is over here, 0.375. So it's going to be 0.375 and then to the power of 2. And then the Kc value. The Kc value was also given in the question. Here they say the Kc value for this reaction is 10. We have 10 here. So we can substitute 10 here. And then we have to solve the whole thing so that we can find x. And so from here, going down, you just use mathematics. And if we make this thing the subject, what's going to happen? It's going to become, therefore, x minus 0.75 over 2 will be equal to, we are going to take the square root of 10 multiplied by 0.0625. And then on top of the fraction, we have the square. So it's 0.375 and then it's squared. So then it's going to be x equals to 2 multiplied by the whole thing, which is going to be 0.625. And then we still have 0.375. So you use a calculator. You use a calculator here. It gives me 1.75 mole. Oh no, it gives me, sorry. It gives me 1.71 mole. That's what I get, 1.71. So yes, this was a long question, okay? It was a long question, 6.1.2. How many marks is it? It was an 8 mark. It was 8 marks, so it was somewhat of a long question. Okay, let's move on to the next question. 6.1.3, they say calculate the mass of sulfur dioxide that was sealed in the container. Okay, if we have the number of moles, isn't it, we can find the mass. Okay? For 6.1.3, yeah, we know that N equals to M over M. And then so if we want the mass, we just change the subject. And then for sulfur dioxide, it's SO2. So it's going to be 16 multiplied by 2 and then plus sulfur. Sulfur, I think, is how much? Sulfur is 32. You get it, and you get it from the periodic table. This is 32 here. And then you use a calculator again. You use a calculator and it gives me 108.8 grams. You can see 108.8 grams. Okay. Then now here they say what? Certain changes were made to the equilibrium conditions. What effect will they have on the yield of sulfur trioxide? Right, only increases, decreases, or stays the same. If we increase the temperature, okay, if we increase the temperature, which reaction will be favored? So if we increase the temperature, then what will happen? Which reaction is favored? If we increase the temperature, we can see the reverse reaction will be favored here because the forward reaction is exothermic. Okay, the forward reaction is exothermic, so meaning the reverse reaction will be endothermic. And we know that an increase in temperature favors an endothermic reaction. And an endothermic reaction is reverse in this case. So it means that if the reverse reaction is favored, the yield of sulfur trioxide will decrease. Okay. So the increase in temperature will decrease the what? So this answer here, it will be decreases. Okay, because the reverse reaction is favored. Okay. Catalyst added. Okay. The catalyst, it will not have anything on the what? On the yield. The catalyst will speed up the reaction. It will speed up the reaction, but it won't change the yield, the amount of sulfur trioxide that is produced here. So stays the same. Stays the same. And then they say pressure decreased. Use the Shatter's principle to explain your choice. If pressure is decreased, what will happen? Which reaction will be favored? Because this is what we must look at. So pressure is decreased. Which reaction? They say pressure decreased. Yeah, pressure decreased. Okay. If we decrease pressure here, which reaction will be favored? We can see that the reaction that will be favored is the what? Is the reverse reaction, because the reverse reaction has 3 moles and the forward reaction produces what? 2 moles. So a decrease in pressure will favor the reaction that produces more moles, which is the reverse reaction. So it will decrease. Okay. So okay, it will decrease. So we must write the answer here. 6.2.3. Okay. Let's do it. Let me do it here. The top. So 6.2.3. The answer here is what? Decreases. Decreases. And then they say you must explain, use the Chatelier prism. So it's going to be a decrease in temperature, no, a decrease in pressure, sorry. A decrease in pressure favors the reaction that produces more moles, that produces more moles of gas. Okay, so this means what? Because we've seen that the reverse reaction produces 3 moles while the forward reaction produces 2. So this means that the reverse reaction is therefore favored. The reverse reaction is therefore favored. So yes, this is the end. Yes, 6.2 is the end of question 6. It was equilibrium constant. Okay, let us move on to question 7. Okay, let us move on. So it's on the same page. Okay, 7.1 they say, so ammonia is a weak base found in many household cleaning products. Define the term weak base. Okay, 7.1 they want the definition. Define the term weak base. Define the term weak base, yes. 7.1. What is a weak base? A weak base is a base that is a base is an that ionizes incompletely in water to form a low concentration of hydroxide ions. So it ionizes incompletely. This is what? To form a what? A low concentration of hydroxide ions. So a strong base is the opposite. A strong base ionizes completely to form a what? To form a high concentration of hydroxide ions. If they ask you for a strong base, it will be the opposite of what we have here. It will be completely, and then it will be high concentration of hydroxide ions. And then 7.2. So we have to read the paragraph here. They say in an attempt to determine the concentration of ammonia in a local carpet cleaner, Thabo added 20 cubic centimeters of the carpet cleaner to a 250 cubic centimeters volumetric flask and added water up to 250 cubic centimeters mark. 31.2 cubic centimeters of this solution was neutralized by, so they say what? 31.2 of this solution of sulfuric acid of this solution was neutralized by 25 cubic centimeters of sulfuric acid of concentration 0.02. 7.2. Calculate the concentration of hydroxide ions OH in the acid. Oh, okay. Of the hydroxide ion. Okay. In the acid. So, okay. Sulfuric acid is what? It's a diprotic acid, isn't it? So, isn't it we must find the concentration of hydronium first? So, the hydronium ion concentration is going to be equal to 2 multiplied by 0.02, which is going to be 0.04 mole lithium cubed. Then, if we have this, then we can find the what? The hydroxide. So it's going to be H3O, and then it's going to be OH. And then it's going to be 10 negative 14. Okay. So then if we want the OH, then we just make OH the subject. And then, okay, so we substitute H3O here, and then you use a calculator. You use a calculator here. It gives me 2.5 multiplied by 10, negative 13 mole lithium cubed. So, okay, in the beginning, why did we multiply by 2 here? It's because H2O, H2, sulfuric acid is what? It's diprotic. It's diprotic here. Okay, diprotic means what? We multiply by the 2 that you see here. It's the reason we multiply the concentration of the sulfuric acid by 2 is because of this 2 here. See? So that's why we multiply by 2 to get concentration of the hydronium ions. And then let us move on to 7.3. Now 7.3, they say what? So they say the balanced equation for the neutralization reaction is this. So there is ammonia, there is sulfuric acid, and then there is ammonium sulfate. So they say calculate the concentration of the ammonia in the household vinegar. Okay, so what do we have here? So now the first thing is we can get the number of moles here, isn't it, for sulfuric acid? And then we compare that number of moles to what? Ammonia, yes. We can find the number of moles for sulfuric acid first, because we have the concentration and we have the volume. So for 7.3.1, we get the first thing we're going to do here is we're going to get the number of moles, and we're going to say CV. So this is for sulfuric acid. Right? So the C is 0.02. The volume is 25 multiplied by 10 negative 3. Because they gave us the volume in centimeters. Yeah? If they gave us the volume in centimeters, they say 25 centimeters. So it gives us 5 and then multiply by 10, the power of negative 4 moles. And then now, when we have that, then we can find the number of moles of what? Of ammonia, isn't it? Because we can use the balance equation. So we can come here. So we see that it's 1:2. So that for every 1 mole of sulfuric acid, there will be 2 moles of what? Of ammonia. Okay. So then we're going to take it, what we have here will be equal to 2 multiplied by 5 and then times 10 negative 4. So then it's going to be, so you use a calculator here, it's going to be 10 negative 3 moles. So again, why do we multiply by 2 here? Because we can see from the balanced equation that what? NH3 is equal to 2:1. It's 2:1 from the balanced equation. See? So now we have the number of moles, isn't it? Now when we have the number of moles, isn't it? Didn't we also have the volume? They said the volume is 31.2 cubic centimeters. 31 cubic in the household vinegar. We have the 31 here, 0.2, so we can get the concentration in it. So we can come here and we say C equals to N over V, because now we have the number of moles. So this is going to be, the number of moles is 10 negative 3, and then the volume is what we have there. The volume is 31.2 cubic centimeters. So is going to be 31.2 and then multiply by 10, negative 3. So it's going to be equal to so it's going to be 0.032 0.032 moles per what? Per cubic decimeter. Okay, and then after that, okay, we know that this with the NH3 here was taken from what? From the 250 cubic centimeters. So it was taken from the 250 cubic centimeters. Right? So then we can get the number of moles there. Right? We can get the number of moles inside the what? The 250 cubic centimeters. So I hope you're following here. Okay? Because this over here is the what? Is the dilute NH3, meaning inside there in 250 cm cubed. Okay, so then we can get the number of moles. So then we come here, we say n equals to CV. So it's going to be equal to 0. And then it's going to be multiplied by the 250 multiplied by 10, negative 3. So then it gives us the number of moles. Okay. It's giving me 8 multiplied by 10, negative 3 moles. Okay, then we can then go to the 20 centimeters. So then we can then come, this is the number of moles. Then we can then say C equals to N over V. So now this is what we're doing here. We're doing for the concentrated what? We're doing for the concentrated NH3, because then what is happening here is, let me try to explain. What is happening here is the number of moles that we have inside the 250 here, inside the 250 came from where? They came from the 20 cubic centimeters of carpet cleaner. Okay. So all the number of moles that we have inside here came from where? They came from the 20 cubic centimeters. So all those number of moles, then we are going to divide them by the volume of 20. All those number of moles that are inside there, that we find inside 250. Okay, so then this number of moles here, we're going to say 8 multiplied by 10, negative 3, and then 20 cubic centimeters, we say 20, and then we divide by 10, negative 3. Multiplied by that. So, and then you use a calculator here. So then it gives you 0.4 moles per dm cubed. 0.4 moles per cubic decimeter. Okay. So this is the volume that we have. And then 7.3.2, they say at the equivalence point, the pH of the mixture is not 7. State whether the pH is above 7 or below 7. And explain your answer using a relevant equation. Okay. So what we see here is a strong acid and a weak base. Okay. A strong acid and a weak base. So what does that mean? It means it's going to be below 7, isn't it? It's going to be below 7. Yeah, 7.3. Going to be below 7. Below 7. And then they say we must use, if it's going to be below 7, it means more hydronium ions will be formed. Okay. If we want to form more hydronium ions, it means we must use ammonium ions here, NH4. Okay, NH4 is the one that can give away a hydrogen, because they say explain your answer using relevant equation. So it means that we must use hydronium. Okay, what we know is that for something to be below 7, it must be acidic. What makes something acidic is if it has a lot of hydronium ions, H3O. So the equation that you use here must form hydronium ions to justify why the pH is below 7. So what can give away hydrogens here is the ammonium, not ammonia. So ammonium NH4 is what we're going to use as the equation here. So we're going to have NH4 plus and then plus H2O. And then the ammonium is the one that will give away the what? The hydrogen here, or it will give away the proton. So then you have NH3 plus H3O. So this is what makes the solution acidic or below the pH of 7. Okay. And then where do we go from there? 7.4, they say what? A diprotic weak acid ionizes in water in 2 steps as shown in the 2 equations shown below. Okay, so define the term ampholyte. So define the term ampholyte. 7.4.1. They say define the term ampholyte. What is an ampholyte? What is an ampholyte? An ampholyte is a substance that can act as either an acid or a base. That is what an ampholyte is. Okay. It can act as an acid sometimes, and it can act as a base in some situations. So it depends on the situation. 7.4.2, they say, from the above reactions, write down the formulae of the ampholyte. Okay. An ampholyte, it means that in this case, it's going to be so an ampholyte here that we have is going to be H and then C2O4 minus, okay? Because it's a base here because it is given away, and then here it is an acid because it's giving away a hydrogen. So it's an acid here, but then when you come here, it becomes, no, it's a base, sorry. It's a base on the first reaction. On the second reaction, it's an acid. And then they say two acids in equation 1. Okay, two acids in equation 1. This is an acid. This one is an acid because it's giving away a what? It's giving away a proton. So 7.4.3. The one that is clearly an acid, C2 and then O4. So we said that that one is a base. And if that one is a base, so this is an acid, it means this one is going to be a base. That one is going to be a base. That means that one is going to be a what? An acid. So the other acid is what? It's H3O. So those will be the two acids in reaction 1. Okay. So, and again, guys, you don't understand something, please feel free to leave your comments, please. Okay. You leave your comments and I will attend to you. Okay. So that is the end of question 7. It was acids and bases. It's 22 marks. Okay. It's 22 marks and a few long questions. So let's move on to question 8. Question 8, now they're talking about galvanic cells. They say a galvanic cell is a setup under standard conditions. Or a galvanic cell is set up under standard conditions as represented by the cell notation below. Okay, so they gave us a cell notation here. 8.1, they say, define the term galvanic cell. Okay, define the term galvanic cell. 8.1. Define the term galvanic cell. Galvanic cell. So a galvanic cell is a cell in which chemical energy is converted is converted to electrical energy. So this is the what? The definition. And then 8.2. Write down the standard conditions under which the cell operates. Okay, what are the standard conditions? Okay. So the standard conditions is what? Temperature. Temperature of 25 degrees Celsius. Okay, the room temperature. And then concentration of 1 mole per cubic decimeter. Okay, so these are the what? The standard conditions. So write down the standard conditions. So it's 2 marks. So yes, this is enough. Okay. I was gonna talk about pressure, but yeah, no, this is enough. If it's 2 marks, then if you just give 2 conditions, then it is enough. And then 8.3, they say write down the formula of the cathode. Okay. The formula of the cathode. Okay, so we know that when you have a cell notation here, you have the what? On the right, you have the anode, and then on the you have the cathode. On the left, you have the anode. On the right, you have the cathode. Okay. On the right, you have the cathode. So then, so the solution on the right is aqueous. Okay, it's an aqueous solution. So it's aqueous, and then so if it's an aqueous solution, it means the solid that was used here is platinum. So the formula so it's going to be PT. The solid that was used here is platinum, PT. And then the formula of the reducing agent. Okay, the reducing agent undergoes oxidation. So it means they want the anode here, the anode, the one that undergoes oxidation. So the reducing agent here is going to be the anode, which is Cr. See, it's 1 mark, 1 mark. 8.4. They say, what is the total concentration of tin ions in the electrolyte of the tin half cell? What is the total concentration of tin ions? Okay. In the tin half cell. Okay, what is the total of tin ions? Okay, so there are 2 types of what? Of tin ions here. The one has a what? There is the one with a +4, and then there is the one with a +2. Okay, so if we say that the concentration of each thing must be 1 mole per cubic decimeter, okay, because one of the standard conditions is that the concentration must be 1 mole cubic decimeter. But then if you have 2 types of ions, the +4 and the +2, so that means what? That will double the concentration. Okay, so the concentration here for 8.4 will be 2 moles per cubic decimeter. a cubic decimeter. So they say, calculate the initial EMF of the cell. Okay. The initial EMF of the cell. So we have to go to the table, isn't it? The formula. What is the formula for the EMF of the cell? Then the formula E cell. Okay. This is 8.6. E of the cell, what would it be? It's going to be E, and then cathode, minus E, anode. So, we know that, okay, in our case here, the anode is going to be, okay, the tin, the cathode is going to be the tin and the krypton. So we have to go to the what? To the table of standard reduction potential. So we have to look for tin. Right? And then we have to look for krypton. Okay, so here we go. Okay, let me just zoom it. Let me just try to zoom it here. We have to look for the values of krypton and tin from a table of standard reduction potentials. Okay, let's just wait. Okay, so here we go. Okay, we go. We look for tin and krypton. So here is the two types of ions that we had there. So we know that for tin we have 0.15. Okay, so it's positive 0.15. And then for krypton, so for krypton, we don't have a positive 2 in our question. Okay, so we have the Cr. So again, this is another thing that is confusing about this. Okay, is that there are many equations for Cr krypton, but then we have to look at what we have in the question. Okay, in the question we don't have this over here, Cr2. We don't have it. We have Cr. So we're going to take this negative 0.74. So it's going to be 0.15 and negative 0.74. So we go back. So it's going to be positive 0.15 and then minus negative 0.74. So again, let me show you on the question here. For our thing here, we have Cr, you see. We don't have Cr2 plus. We don't have this. So that's why we took the other one, because there were two equations, so it becomes confusing which one you should take. You look at what we're given in the question. So this is the anode, this is the cathode. So, and then, so that's what we do here. So then the E, again, you use a calculator here. You just press all those numbers into your calculator. It gives me positive 0.89 volt. Gives me positive 0.89 volts. How does an increase in initial concentration of krypton ions affect the voltmeter reading? Write down only increases, decreases, or remains the same. So krypton will be here. It will be the anode. Okay. To be the anode. So we add more krypton ions to the anode. The anode is the what? Is the negative part. So what that means is that affect the voltmeter. If we increase the negative part, the anode will decrease. It will be decrease. The voltmeter reading will decrease. So the answer here becomes decreases. Okay. So that is the end of question 8. So again, you are free to leave your questions in the comment section if there is something you want me to clarify. Okay. You can always leave your comments and then I will attend to your comments, please. So, okay, let's move on to question 9. You say what? Copper metal of very high purity is required to manufacture electrical copper cables. The diagram below shows an electrochemical cell used to purify copper. Okay. So there is pure copper and there is impure copper. Then there's acidified solution of copper sulfate. Define the term electrolysis. 9.1. Define the term electrolysis. What is electrolysis? Electrolysis. Electrolysis is the chemical process in which electrical energy is converted to chemical energy. So that's what electrolysis is. So, and then 9.2, they say, write down a balanced equation for the anode half reaction. Write down a balanced equation for the anode half reaction. The balanced equation for the anode half reaction. Okay, we know that the anode will be where oxidation happens. So it will be the pure copper. Oh no, it will be the impure copper. Okay, for the anode half fraction, that's where oxidation happens, isn't it? So copper will be, so, okay. The anode, that's where oxidation happens. So it will be from copper like this to, so they say copper sulfate. So it means that it will be 2. So and then 9.3. So this will be the oxidation engine. Oh no. And then 9.3, they say, which electrode is the positive electrode of the cell? Write down pure copper or impure copper. Okay, so we know that the anode, okay, which anode is the positive electrode? We know that the anode is the positive electrode. And if you have an electrolytic cell, okay, so it means that the positive electrode will be the anode, isn't it? So it will be the impure copper. So let me just underline it. It will be this. It will be the impure copper. Okay. It's just one mark. Because that's where the anode will be. That's where oxidation will take place. You see. Now 9.4 they say the impure copper contains zinc, silver, gold, and nickel as impurities. Identify one impurity that may be oxidized. Okay. The one impurity that may be oxidized here is what? Okay, zinc, because it is a better reducing agent than copper. Okay. Okay, let's go to the again, increasing reducing ability. You see here, we have copper where? So you have to compare. We have copper here. We have copper here. And then where do we have zinc? Um, and then we have to look for zinc. Where's zinc? Why can't I find the zinc? Oh, zinc is here. You see, now it has, you see, what they say here is that this is increasing reducing ability. So it means that zinc is a better reducing agent, that it has a higher reducing ability than copper, because copper is here and zinc is down there. So it has a greater reducing ability than even nickel. So even nickel here, you see, nickel and even zinc, they have a greater reducing ability. So you can say zinc or nickel. Okay. And then they say, explain your answer to 9 point. I think they were trying to say 9.4.1. This is what I was just explaining, is that So 9.4.2. Yes, 9.4.2. You can say zinc has a higher reducing ability, than copper. Okay? Or you can say what? Zinc is a stronger reducing agent. Is a stronger reducing agent than copper. So that is the reason. So that is another reason that you can give here. Okay. And then you could say the same thing. You could say the same thing about nickel. So instead of zinc here, we could also use nickel. And then anything is the same. Then 9.4.3. 9.4.3. They say state what happens to the impurities that are not oxidized. State what happens to the impurities that are not oxidized. So the impurities that are not oxidized so state what will happen to the impurities that are not oxidized. Okay. 9.4.3. They will fall to the bottom. To the bottom. And then the next one says, a current was passed through the solution for a certain period of time. The electrodes were weighed before and after the electrolysis. After electrolysis, the results are shown in the table below. Okay. So mass of impure copper and mass of pure copper. So after electrolysis, so the mass of the impure copper has reduced. Okay. The mass of the pure copper has increased. So they say use the information in the table to calculate the percentage purity of the impure copper. Okay. The percentage purity of the impure copper. So for 9.5, so we have to compare, isn't it? So we have to look at the change in the mass of pure copper. Right? So we have to look at the change in the mass of pure copper. Right? So the change in mass, pure copper, right, will be equal to 320 minus 150. So then it will be equal to, they give us, you use a calculator there, 320 minus 150, and then it gives us 170 grams. Okay. And then we have to, because the question is saying, use them to calculate the percentage purity of the impure copper. Then we have to say, because before it was 600, and then after it was 390. Okay. Again, we have to change the mass. We have to calculate the change in mass for the impure copper. So the change in mass for impure copper will be equal to 600 minus 390. Okay. 600 minus 390 equals to. So, and then so the percentage purity, okay, percentage purity will be equal to pure over impure. And then we multiply by 100, okay? So then it's gonna be, okay, here we say 600 minus 390, it gives you 210 grams. So then impure is gonna be 170 over 210 multiplied by 100. So it's gonna be, you use a calculator, we get, it gives me 80.95%. That's what I get. What happens to the concentration of the electrolyte during the process? Explain your answer. Okay. What happens to the concentration of the electrolyte during the process? And then they say, you must explain your answer. The concentration of the electrolyte, what? It remains constant. It remains constant. Why do we say this? It remains constant because whatever is taken up by the pure mass is being replaced by the impure mass, okay? It remains constant, okay? Here, the rate of oxidation, oxidation of copper is equal to the rate of reduction of copper ions. So whatever comes out of the impure copper, which is the anode, is the one that will go to the pure copper, which is the cathode, where reduction happens. See? So it remains constant because whatever it taken in to the electrolyte, the same amount will be taken out of the electrolyte. So the concentration remains constant for the electrolyte. Okay. So yes, guys, this was This was 150 marks, so this was paper 2. Okay, I hope it was helpful. I hope that you got something out of this. So again, thank you for tuning in into Metric Hub. So please leave your questions and your comments in the comment section. We're going to do more papers. Okay, we're going to do more papers as we are preparing for the upcoming trial exam. Okay, leave your questions in the comment section, please, and leave your comment there. I will attend to as many of you as I can. Okay. Again, thank you for tuning in. Thank you for tuning in again. Please stay focused. Bye-bye for now and take care. Okay. We'll see you on the next one.